Was it a specific day or
For Wednesday.
just Wednesday? Oh, that's next week. Okay. Oh. So from the scatter plots we were doing last class, remember the R squared tells you how strong the data is? And so if R squared is 1, then all of the points land on the line.
Okay.
That's
Thank you.
all it was. Uh-huh.
Thank you.
But that question will be on the exam, so it's a good thing. We go over it. So if R squared is 1, all the points land on the line. Any questions on that?
No, thank you.
Mm-hmm. Any other questions before we start? Today we're going to cover section 2.3. And the first group, you'll want to go on Desmos. To solve by graphing, unless you're using technology, you don't want to do it by hand because if your graph's a little bit off, you're going to have a wrong answer. So we're going to use Desmos. So if we look at this first one, solve by graphing A, you just put both equations in and have it graph them. So if we go y equals 3x minus 12, and then plug the second one in, and then you want to see where they intersect. It's 4x plus 2. Now notice it doesn't show. When it doesn't show, you don't really want to do a window because with the scatter plot, we can see our x values and our y values to make a window. But here, we would just be guessing. So you can use, depending on if you need to zoom in or out. This one we want to zoom out so we can see more material. There it is. You can go and click on it and it will give you your answer. So these two equations, their solution is -14, -54. That is the one point they have in common. Any questions on that? So I just typed both equations and let's try the second one. Y equals 2x plus 7. Y equals 2x minus 5. You should have two parallel lines, and no matter how much you zoom in, they are never going to intersect because they're parallel. That means there's no solution. They never intersect, no solution. Any questions on that? Another thing that can happen is, well, we got one solution. Here's no solutions. There can be many solutions. And when that happens, it's because one line's on top of the other. So we could do 2y equals 4x plus 14. Notice the two lines landed on top of each other. I just took the first equation and multiplied it all by 2. So they're the same equation, just one is simplified and one isn't. That's why if I have you find equations, I'll always have you solve for y. That way it's simplified. But if one line lands right on top of the other, this would be infinitely many solutions. So there's one solution, no solution, or infinitely many. Any questions on that? So if I had you graph two lines on the exam to see where they intersect, that would be a take home since you'd be using Desmos. And the exam's 1 week from today. Any questions on that one? The second group is by substitution. For substitution, erase my highlights from my last class. For substitution, you're plugging one equation into another. So we know that x equals 5y plus 12. I can plug this highlighted part in for x, because that's what x equals. X equals 5y plus 12, and I can plug that into 3x plus 4y equals a negative 2. So you're taking this and plugging it in there. Distribute the 3. So 15y plus 36 plus the 4y equals a negative 2. Combine like terms. 19y plus 36 equals a negative 2. Subtract the 36. 19y equals a negative 38. And divide by 19. Now what you want to be careful of is you're not finished because you need to find x and y. So whenever you get an answer, always check what that's asking for. In this case, if they want you to find where the two intersect, you need a point, not just a y. You can plug it into either one of the original equations. I'm going to plug it into the top one. X equals 5 times y is a negative 2 plus 10 plus 12 is a positive 2. 2, negative 2. Any questions on that? The second one, part B, 2x plus 5y equals 6, and x plus 2.5y equals 3. Now, this is one that, of course, we haven't learned elimination yet, which is the next one. You might want to use elimination on instead of substitution because it's not solved for a variable. Where this one was solved for x, we just plug that in. These ones are not. If we look at this one, if we solve for x, we're going to have to divide by a 2. Here we'd have to divide by 5. But this one here, if we subtract the 2.5y to the other side, then it's solved for x. So anytime you have to do it a certain way, see which is going to be the easiest to solve for. And this one can just subtract this to the other side. Then I can plug this in. Any questions on that? And then plug it in. Distribute our 2. Notice what happens though. All our variables dropped out. We get a true statement. If you get a true statement, these are actually the same lines. If you multiply this one by 2, you have the same one. So if you graphed them, they'd be on top of each other. This is infinitely many solutions. If the variables drop out and this is not equal to each other, then it's a no solution. And that'll happen in the next group. Because they're equal, infinitely many. Any questions? The next one is elimination. And if we look at the first group, we have x plus 3y equals 5 and 2x plus 4y equals 8. Now you want to be able to add down and have one of the variables be eliminated. And you could think of common denominators. We have 1 and 2. We could make both of these a 2, one positive and one negative, and they'll drop out. Here, the smallest number that they both go into is 12. So we need to make a positive 12 and a negative 12, which means a lot larger numbers. Any questions on that part? So I want to be able to add down and have it drop out. Kind of like we did here, the negative 5 and the positive 5 canceled. That's what I want here. So if we look at this top one, if I multiply it by a negative 2, I'm going to have negative 2x and a positive 2x, and when I add down, the x's will drop out. Any questions? So I'm only going to multiply the top. So we have a negative 2x, 6y equals a negative 10. Second one is 2x plus 4y equals 8. I'm not multiplying the bottom one, I'm only multiplying the top one. Any questions? Notice when you add down, the x's drop out. You have negative 2y equals a negative 2. Divide by the negative 2. X is a positive 1. Of course, we only found x. We still need to find y. But any questions on that part? So then we plug 1 in for x and solve. Subtract the 1. And divide by 3. For some reason, I don't remember having a fraction earlier. So y is 4/3. Any questions on that?
Yeah, for the first part, when we get rid of the x, I thought we were solving for y on the right
All
hand
right,
side.
you're right. I knew I made a mistake somewhere.
Oh, okay, yeah. Thank you so much.
Yeah, sorry about that. Yeah, I had the y above it. I don't know how I switched, but this should still be y. Not that you couldn't have a fraction. I just know I didn't have a fraction earlier. Um, so y is a positive 1. Place of y, I'm going to put 1. Now I chose this one because then I'd have x right away. Here I'd have to divide by 2. Either case, you'll get the same answer. X plus 3 equals 5 and subtract the 3. That's better. So your answer is 2, 1. But any questions on the elimination? We'll do the second one. Questions? Okay, go ahead and try B. Now, when I'm looking at one like this one, I can see the x's here. If I multiply to get the x's to drop out, what should I multiply the bottom row by?
2?
Okay, so if I multiply by 2, I'll have a positive 6. And if I want them to drop out,
Oh, make it a -2 then?
there we go. Yep. Because you want them to be opposite signs. Now you could check the y's also, but we have a decimal in here. I'm not even going to mess with the decimal. This is easier to multiply by -2. So the top we're not changing. On the bottom we're using a -2 because then when we multiply the first group, we have a -6x. Our x's are going to be eliminated. And then -2 times 4.5 is a positive 9y. And -2 times -6 is a positive 12. Notice both variables are eliminated. Kind of like we had in 2b above. The only difference is, so these two are eliminated, we're left with a 0. But on the other side, we have 24, which is not true. When it ends up not equal, then it's no solution. So if it's a true statement, it's infinitely many solutions when your variables drop out. And if it's not true, it's no solution. Any questions on that? These problems will use these different ways of solving. But first of all, break even. We did a few problems this week where we found when the company is no longer at a loss, how many do they need to produce and sell so you're no longer at a loss? That's your break even quantity. So if you want to know when you're no longer at a loss, you're finding your break even quantity. They're the same thing. Now we did the second one. We set the profit equal to 0, but you can also set revenue equal to cost. So to find break even, or when the company's no longer at a loss, set revenue equal to cost or profit equal to 0. We look at number 4. And these problems are all on As You Learn under section 2.3. I put them on so you don't have to write them out. A manufacturer of sinks has a total revenue given by R of X equals 76.5 and cost 70 plus 27. Find the number of units that gives the break even for the product. So we want to find the break even quantity. Break even, you set the two equal. This would be like substitution. So I set revenue equal to cost. I'm going to subtract the 27x to the other side to combine the x's. Any questions on that part? Then we divide by the 49.5. So x equals 60 sinks. They need to produce and sell 60 sinks in order to break even, which means they were no longer at a loss. Any questions on that? This one came out to a whole number, but if it came out to a fraction, even if it was 59.0001, you're not going to break even unless you round up. So when you're working with revenue or profit, always round up if you need an integer. We're not going to sell part of a sink. So if this would have been a decimal, whatever decimal was on there, we'd round up. Cost, round down. If you had $10,000 and you could produce 49.99999, you don't have enough money to produce the rest of it. You round down always. Or just drop the decimal. So revenue and profit, if it should be a whole number, which in most cases it should. Decimal ones would be pounds of coffee, that can be in decimals. crates, you probably could sell half of a crate. But sinks, computers, televisions, you don't sell part of one. And so revenue and profit round up, cost round down. Rounding down means you drop the decimal. So 49.999 would be 49. Any questions on that? A certain product has a supply and demand function given as supply E equals 5Q plus 20 and demand P equals 128 minus 4Q. If the price P is $60. So if they're selling them for $60 a unit, how many units are supplied and how many are demanded? So for our supply, they gave us P, so we plug P into the equation. And then solve. If we plug 60 in for P, what do we get for our quantity? Getting 8. So if we sell them for $60 each, we will create 8 of them. Eight, I think it's just units. If we find the demand, plugging in again 60 for P, subtract the 120, 128. And divide by the -4. So if they sell them for $60 each, they will build 18 units and sell them, but the demand is for 17 of them at that price. So then there's a shortage. And a lot of customers who are unhappy. Any questions on that? So if they sell them for $60 each, the company will supply 18 of them, but the public wants 17. So they're not getting everything they want. Any questions on that? Well, there's a way to make both ends happy, and that's called the equilibrium. I think that's what the next one. Oh. The equilibrium is when the supply equals the demand. So we want those two equations to intersect at a point. And B asks you to find the equilibrium. To do that, we set the two equal. There's two ways we can do it. We can use elimination or we can use substitution. Notice it's already solved for a variable, so we could just substitute this in for P. Add the 4Q to the other side. Now, if you can subtract the 20 at the same time, definitely do that. We have 9Q plus 20 equals 128. Subtract the 20. And divide by 9. So if we build 12 units, our demand will be 12 units. So we will sell everything. But to find the price, you need to plug 12 into either one of the equations. You will get the same answer either way. Take the first one. 5 times 12 plus 20. But if you plug 12 in here, you'll get the same answer. So if we sell them for $80 instead of the $60, we will build 12 of them and we will sell all 12 because that will be our demand. So our supply and our demand will be equal, in equilibrium. Any questions on that? Number 6. A concept promoter needs to make 84,000 from the sale of 2,400 tickets. The promoter charges $30 for some tickets and $45 for others. If there are X of the $30 tickets and Y of the $45 tickets. So when you're reading an equation and they give you what the variables stand for, you could just circle that or write it. But anytime your variables stand for certain things, you need to mark it somehow. Sometimes they give you it, sometimes you choose. Like in the next one, we're going to choose. But in this one, they told us what X and Y stood for. On a test, I would just say, find out how many tickets of each should be sold. I would not guide you with all of this, especially B and C. But part A, if there are X of the $30 tickets and Y of the $45 tickets, write an equation that states the total number of tickets sold is 2,400. So total number means we're adding the number of tickets together, and is means equals. So X plus Y, because that's how many of each ticket are being sold, The two together should give you the total number of tickets, which is 24. An equation has an equal sign. Part B says expression. An expression is part of an equation. Like this is an expression, just X. Write an expression that shows the amount of money received from selling X tickets at $30 each. Well, if we have X tickets and they're $30 each, if we want to know how much revenue it's bringing in, we'd multiply that together. 30X. Because if we sell 10 of these tickets, 10 times 30, $300. And that's an expression. An expression does not have an equal sign. Part C, write an expression that shows amount of money received from selling Y tickets at $45 each. Y of them, $45 each, 45 Y. So this is the amount of money we bring in for both tickets. Questions? Write an equation that states the total amount received from sales is 84,000. Well, this is the amount we're making on each set of tickets. The two together is $84,000. Any questions on that? For part E, it says how many tickets must be sold at each price to yield the 84,000. We want to know how many tickets at each one. Looking for X and Y. Well, we have two equations. If we use elimination, what can we multiply the bottom row by to make one of the variables drop out?
30.
Positive or negative?
Negative.
Right. So if we multiply by a negative 30, notice this would be negative 30x and they'll drop out. You have to remember that you have to multiply everything by that. So the top will stay the same. Now you could have also multiplied by a negative 45 and the y's would drop out. Negative 30x 30y equals negative 72,000. Any questions on that part? Going down, we have 15y equals 12,000. Divide by the 15. Got 800. Any questions on that part? We have y, we need to find x. I would use this equation. That way I only need to subtract the 800. Sell 1,600 tickets at $30 each. And 800 at 45 each. Is there any questions on that? Open this a little so you could see it. A woman invests $52,000 into two different mutual funds, one that averages 10% and the other 14% per year. Her average annual return on the two funds is $5,720. How much did she invest in each? So we have two, and we want the amount invested. So I'm going to let X be the amount she invested at the 10%, and Y the amount she invested so I think it was 14%. When it doesn't have them labeled like the one before, you need to label it. That way, when you get to the answers, you're not going crazy trying to remember which stood for which. Now we need two equations. She invested $52,000. Well, X is the amount invested in the one, Y is the amount in the other one, so the two together should be 52,000. The other total they gave us was the amount of her return. When you're talking about a simple interest, the amount that you make, this one's 10%. You need to write it as a decimal. So either divide by 100 or move over to the left 2. So the interest that this would make, this one, would be 0.10 times x, or 0.1. This one, moving our decimal, we get 1400ths. It would be 0.14 times y. This will be how much interest we make. And the two interests together is the 5720. Any questions on that? What could we multiply by to get the x's to drop off? Anyone? Well, if you want to keep the decimal, you could multiply the top by a negative 0.1. Or we could multiply the bottom by a negative 10, and our x's would drop out. The y's we'd have to multiply by a negative 0.14 here or a negative 100 here. I would multiply this one by negative 10, so I'm kind of eliminating at least some of the decimals. X plus Y equals 52,000. Multiplying by a negative 10, we have a negative X minus 0.4Y equals negative 57,200. Any questions? You go ahead and solve for Y. Be careful, there was a 1 here, negative 1.4. Are you getting 13,000 for Y? This is the amount that was invested at 14%. Because I wrote it up here, I don't have to go very far to look for it. $13,000 at 14%. To find X, plug it into either one of the original. I'd use the first one. Subtract the 13,000. So she would invest $39,000 at 10% and 13,000 at 14%, and she will make $5,720 in a year. Any questions on that? So you need to be able to set up the equations and solve them. There's at least one, if not two, on the in-class portion. Any questions?